I'm going to show you how to use data analysis and the t-test for two samples. First, to do the hypothesis testing, as well as how to come up with the confidence interval for the difference we see between two populations. The manager of a store would like to know if the average daily sales measured in dollars through her websites are any different than her in-store sales. The data has been collected, and we want to do an analysis at 5% level of significance. So first of all she's wondering is that, is there a difference between online and in-store? So our null hypothesis is that there is no difference between the two, right? This is the online sales is the same thing as the store sales. And the alternate would be that, no, they're not the same. So this is what we are checking. And again, what I said was that if you write it like this, might be easier for you to see what we're doing. So now we're going to say that the difference between the two, so if I have to take the two mu's, I am saying that these are equal to 0 or it is not equal to 0. So this is the online and this is the store. My handwriting isn't so good, so I'm not going to follow it. Now let's go look at our data and do the analysis. So here's our data. These are dollars that has been recorded at the end of day for several days that we have taken the observations from online and in-store. So the first thing we want to do is go to data analysis, select t-test, again unequal variances. I will assume that I don't want to simplify it, so then I say okay, and it will ask for range 1. And I have shown you that you can click here and do Control Shift down. You could actually do this quicker by just selecting the column. This will work in this type of analysis. If it works only in few places, not all the time you can use this kind of a selection, but here you can, and that will speed up the selection process. So then the second variables appear in the B column. I assume that there is no differences. I have no preconceived idea. I'm going to say that we have labels. I'm going to select the output range, click here, click somewhere here, and then say okay. And here we go. So once again, I know that I am doing a two-tailed test because it was an equal versus inequality. So what I need to do is that I just need to focus on the two-tailed part of this output. And that would be right here. So now looking at the p-value, the p-value is less than 0.05. So I will end up rejecting the null hypothesis, which was the two are the same. So now that I know that they're different, I want to know what is the expected difference between an online versus the store sales. So now I can go ahead and use the same output to develop the confidence interval for the difference that exists between the two channels of sales. So to develop the confidence interval, the difference between the two channels of sales, these are the mean differences between the two. So let me highlight these in red. But this is not enough. So I cannot just take the difference between these two and say this is what I expect the difference to be. There is a margin of error. There is some variability from sample to sample. So what we want to do is develop that entire difference. So right now I can look at the mean differences between the two and say this is x bar 1 minus x bar 2. So I can develop this by saying this minus this value. And by the way, it doesn't matter which one you do first. Your signs will change, but the absolute value of the differences are still the same. And that's what we care about. We either would say right now it looks like mean sales in online is $105 less than what is in store. If you did it the other way around, this positive number would say that in-store sales is $105 more than online. So there is really no difference. So going back to the formula that we have for the confidence interval of the differences, the next thing that I need to find out is what is my t-value. Now the confidence interval is always a two-tail. Margin of error can occur plus or minus. So the two-tail here is 1.99. That's my t-value. So again, looking at our formula, the next thing that I need in order for me to come up with the margin of error is the standard error. And the standard error based on our equation is just the square root of the variance of the first one divided by its sample, and in this case was 52, plus the second sample's variance divided by its sample size. And once I have the two, I can use the square root and find the standard error. Now I'm ready to calculate the margin of error. Margin of error is simply your t-value times the standard error. And now I'm ready to calculate the lower bound and the upper bound of the differences between these two channels. The lower bound is this value minus the margin of error, and the upper bound is this value plus. So essentially what we are saying is that you're 95% confident that the difference that exists between sales online versus sales in store is that the online channel can sell on average about $18.80 per day up to $192.65 per day less than what we'd have as sales for our in-store. Now, as I have said before, that is showing that there is a significant difference, statistically a significant difference between the two. But in practice, that could be as little as $18 difference between the two. So as a manager, you may decide that this is not important to you. It's not enough differences. So statistically significant does not mean that you have found something meaningful at times. Now, if this number was thousands of dollars differences, then nobody would argue that even in practice you would consider that as an important issue. What is the threshold where you as a business person will decide this is significant enough? Really depends on the domain and the decisions that has to go along with that domain. So there is no standard answer for that. This is where your expertise come into play, and it's not just about the statistical values that you're seeing.